Number 44. Which of the following pairs of compounds form a solution? We've got 4 pairs. Now you should remember the like dissolves like rule, so let's examine each of these pairs and see if they're like each other, and if so, they'll form a solution. Number 44. A. The first one is KCl, that's potassium chloride. This is an ionic compound, because you got the metal and the non-metal. And the charge on the potassium is +1, the chlorine is -1, so these are your ions. This is an ionic compound. So what about the other one? Carbon tetrachloride, CCl4. Now, this is a tetrahedral structure. The carbon's tetrahedrally surrounded by the 4 chlorines. And this is a nonpolar covalent compound. So ionic compounds oftentimes will dissolve in water, which is a very polar liquid, but they will not dissolve in nonpolar liquids like carbon tetrachloride. So no solution. The next pair is water and propanol. Water and 1-propanol. So 1-propanol, here's the formula, but I went ahead and wrote the formula like this. So this kind of tells you what 1-propanol looks like. So the OH group is attached to the first carbon. Okay, that makes it 1-propanol. If the OH group were attached to the middle carbon, that would be called isopropyl alcohol or isopropanol. But this is 1-propanol. It's attached to the end carbon. So anyway, here's the water, here's the 1-propanol. These are both going to be polar substances. The presence of the OH group, in fact, allow both of them to hydrogen bond. And 1-propanol does have a large hydrocarbon end, but it's not too large. You know, if you got like 7, 8 carbons over here and just one little oxygen over there, that might make it non-polar enough so that it won't mix with water. But this is a pretty polar substance. It hydrogen bonds, in fact, and these are going to form a solution. The next one, C, cyclodecanone. Here's the formula in water. So cyclodecanone, this is the actual structure of the molecule. It's a nice ring-shaped structure, as you know. The name indicates this, cyclo and decanone. This is a ketone. Whenever you see "-one", that's a ketone. That means you have carbon double bonded to an oxygen, and then on both sides it goes to a hydrocarbon. But since this is a cyclo, the rest of them will form a ring. It'll come back around. So anyway, this is a structure. You do have an oxygen pulling electrons away from this carbon, but this is a huge hydrocarbon chain. So this is mostly a nonpolar molecule, nonpolar covalent molecule. Water, on the other hand, is very polar. It can hydrogen bond, in fact. So nonpolar does not really mix with polar. No solution. The last one's pretty easy. You got pentane and hexine. These are both 2 hydrocarbons. Pentane, here's its structure, and hexane, here's its structure, a little bit longer. But you should get this right away. They're both hydrocarbons. They're both going to be nonpolar, and they will mix together like dissolves like. It will form a solution.